The table below shows the average height of a tree and the amount of years that it has been growing. What is the average rate of change in height of the tree from year 1 to 5? So our question is asking us for the average rate of change from year 1 to year 5. So in order to do rate of change, we know the slope formula, because slope and rate of change are the same. So m equals y2 minus y1 over x2 minus x1 is our slope formula. In order to use that slope formula, we need 2 points. So we need a point for year 1 and year 5, because that is what the question is asking for. So our point for year 1 is going to be 1, 3, knowing that the left column of a table is x, and the right column is going to be y. And for year 5, our point is going to be 5, 3, or 5, 9, sorry. So it should be 5, 9. And then we also need to label our points. So we need to label points our x1, y1, and our x2, y2. So our x's are the first number in each point. So this is going to be x1, and the 5 is going to be x2. And then for our y's, the 3 is going to be y1, and the 9 is going to be y2. Now that we have that, we can go ahead and plug into the formula. So our slope equals y2, which is 9, minus our y1, which is 3, divided by our x2, which is 5, and our x1, which is 1. Now all we have to do is just do our math. So 9 minus 3 is going to be 6, divided by 5 minus 1, which is 4. So then we just reduce that number, and we get m equals, so we know 2 goes into 6 3 times, and 2 goes into 4 2 times, which is 3 over 2. Since our answers are written in decimals, we divide that, and 3 divided by 2 is 1.5. To figure out our units, okay, we look at our x's, which is years, so down here it's years, right? And on top, our y's are feet, so it's feet per year, so 1.5 feet per year. So your answer is going to be C. 26. The boiling point of water, T, measured in degrees, at an altitude, A, measured in feet, is modeled by the function T of A equals negative 0.0018 A plus 212. In terms of altitude and temperature, which statement described the meaning of the y-intercept? So first off, we need to know what the y-intercept is. And on a graph, our y-intercept, if this is your x-axis and this is your y-axis, our y-intercept is where x equals 0. So we know x is 0 at the origin. So every point here, so this is a y-intercept because it falls on the y-axis, and x is 0. So is this, and so on. Any point I put on this line is a y-intercept because x equals 0, and it falls on the y-axis. So if we look, where a is 0, because a is your x in this case, where a is 0, so if we take t of 0 equals negative 0.000, no, oh, sorry, just 2 zeros. So let's write it like they wrote it in the problem. That might make it easier on us. 0.0018 times our a value of 0, so we can find our y-intercept, plus 212. So what we have here is we know that anything times 0 is 0, so that cancels out. So we know our y-intercept is 212. So where our altitude is 0, we know that our T, which is our temperature, equals 212. So our answer is choice B. The boiling point of water at an altitude of 0, which is what we plugged in, is 212 degrees, and that is true, and that's all there is to it. 32. The table below shows the amount of shoes purchased at Shoes Unlimited. What is the meaning of the slope of the linear model for the data? So, as long as it's linear and it changes at the same time, you can find the slope without actually pulling out 2 points like we did earlier. So the other option for finding slope is you can go 2 to 4, we know is plus 2. 4 to 6, we know is plus 2. 6 to 8 is plus 2. And I just wrote plus 6 up there. Let's fix that first. Okay, so that's plus 2. And 8 to 10 is plus 2. Okay, and we also need to go ahead and check the bottom. So 30 to 60 is plus 30. 60 to 90 is plus 30. 90 to 120 is plus 30. And 120 to 150 is plus 30. Since there's a constant rate of change on the top and a constant rate of change on the bottom, we can go ahead and do change in y over a change in x, which is going to be 30 over 2, which equals 15. So we know our slope is 15. This works because in the slope formula, y2 minus y1 over x2 minus x1, we did the same thing just by counting. If you wanted to use the slope formula, you certainly could. So we know that our y's are on the bottom of the table. Let's write the right letter here. Okay, so y's on the bottom and x's are on the top. So just so we know our units to interpret for our x's, it's going to be hours. Okay, so that goes on the bottom. And our y's on the top are going to be shoes. So shoes. So shoes per hour. So it's either going to be B or C because those have the 15 in them. The store sells 15 pairs of shoes every hour, or the store sells 15 pairs of shoes every 2 hours. So it says shoes per hour for our units, so we know our answer is B, 15 pairs of shoes per hour. And we're done. 37. Bobby noticed that there are multiple combinations of nickels and dimes that add up to 75 cents. Let X be the number of nickels, let Y be the number of dimes. What is the domain where Y is a function of X and the total value of the coins is 75 cents? So it's asking what is the domain. So we know domain are our X values. And up here it says let X be your number of nickels. Nickels are 0.05 cents, right? 5 cents. So we have to think logically about this problem. So think about money. So if 0 is a possible combination of the number of nickels. So you have 0 nickels, that means you have all dimes. So dimes are 10 cents. So is there any way you can get 75 cents by using 10 cents? So going by tens. The answer is no, because 10, 20, 30, 40, 50, 60, 70, 80, you skip right over 75. So anything with a 0 in it can't work. So we can go ahead and get rid of A and C. So we look at B. We have one could work, okay, because you could have 6 dimes, and you could have 6 dimes, so it would be 0.10, 0.10, plus 0.10, plus 0.10, 1, 2, 3, 4, plus 0.10, plus 0.10. So that's 1, 2, 3, 4, 5, 6. So that's 60 cents. So you can have whoops. Hold on. Sorry. Let's forget about that for a second. So we were looking at one. We realized we can have. Oh yeah. So you can have 1 nickel, because you can have 6 dimes and 1 nickel, that equals 75 cents. If you have 2 nickels, okay, 5 cents and 5 cents is 10 cents. So that leaves us with not enough dimes to get us to 75 cents. So no way can dimes get us from 10 cents to 75 cents. So we can't have a 2. So now we can get rid of the what with a 2. We look at D. So we can have 1 nickel. We can have 3 nickels. We can have 5, 7, 9, 11, 13, and 15 because they're odd numbers. So we're always going to have an ending in 5. So that is why the answer is D. 39.